Hello everybody and welcome to our webinar today titled MapReduce in .NET, Asynchronous Job Processing. My name is Jeremy Lehner with FatCloud and I want to thank all of you for joining us today. Before we get started, I just wanted to cover a few housekeeping items. If you're using the VoIP on your computer for the audio portion of this presentation and experience any problems, simply just disconnect and call in the phone number provided, or log out of the system completely and log back in, and it should clear up your line. If you have any questions during any portion of today's webinar, please post your questions in the box on your screen. We will do our best to answer those questions in the order they're received, but for any reason we're unable to answer all of the questions posted, we will make sure to personally follow up after the webinar concludes via email. So now let me introduce today's speaker. Justin Weiler is our Chief Technology Officer here at FatCloud, and he has been the lead architect for the technology since inception over 5 years ago. He has over 20 years of software development experience with a great deal of focus on building large enterprise systems. Prior to joining FatCloud, Justin spent time at Experian, Reuters, and Northrop Grumman, to name a few. So without further ado, let me hand it over to Justin.
Hi guys, thanks for joining. Today I'm going to describe some of our asynchronous job processing capabilities that's built into the FatDB platform. Typically, when you talk MapReduce, the canonical example is a word count example where occurrences of words are computed from an input text file. So without further ado, let me sort of jump into some background here. This is a picture of the FatDB distributed ecosystem, and this is a per node example. So basically, when you install FatDB platform, you get three main components. The FatDB, which is our document and key value oriented NoSQL database, and has link and SQL integration capabilities in it. It's pretty cool, pretty full-featured. We have our FatFMS, which is our distributed file management system. It basically clusters a bunch of computers together, their hard drives, and it acts as one large distributed data store. The cool thing about it is that you can tag files with metadata and to search upon them and have variable number of redundancy for input files and whatnot. So it's kind of an essential component for any large-scale enterprise application. And the last thing which we're going to be focusing on today is the Fat Work Queue, which is our asynchronous work queue engine. And it allows us basically, it allows you, the developer, to code up just about anything in C#, deploy those processors to your cluster, and perform any sort of work that you need to do in an asynchronous manner. Examples of this work could be, say, transcoding media files, computing stock market portfolios, doing, say, weather simulation, computing the digits of pi, et cetera, et cetera. We've had customers use them for email blasts, all sorts of stuff. And typically, you find folks using SQL Server to manage their queues, manage their workflows, and stuff like that. And SQL Server can't really keep up very effectively. So this is a great tool for you to do asynchronous work. And both the FatWQ and FatFMS are backed by FatDB, so you get your redundancy and scalability built in. Now, one thing I didn't mention was that if you want to do synchronous stuff and you're used to writing WCF services, you can write those WCF services, inherit from a couple of, a base class or two, and deploy them into your cluster, and they will scale right alongside your data. And this is a huge value add that other PaaSes and Windows, Azure, etc. just don't provide. So the FatDB platform is a nice integrated solution for building all sorts of large-scale enterprise applications. So let's talk about why we're here. How would we go about doing a MapReduce type word count? Well, the basic the basic task that we want to accomplish with a word count is to take an input text file, divide it into chunks, store those chunks into FatDB, take each of those chunks in parallel, and count the word stems that we wish to count. Right now, we're not doing a whole comprehensive full alpha count. We're specifying some word stems and that we're interested in and seeing the occurrences, and storing those result sets back into FatDB. Then finally, what we're doing in the reduce stage is really consolidating all the results by taking each result set and aggregating the totals, and we're going to store the final result set back into FatDB. So how does that look in terms of a job graph? What does that mean? So if you were to take the workflow and build it out into some simple graph of steps, it would look like this essentially, with the middle tier being right now we show 4 nodes for brevity. In the demo example that I'm going to show you, it actually gets divided up into 12 chunks. So the middle tier you'd see 12 workflow nodes. So we start at step 1, which is partitioning the file into chunks. That is a single process. Then we count the words in each chunk, and we do that in parallel. And then finally, we consolidate the results. And that will actually allow us to do the word counts that we're looking for in a very quick and easy way. And let me go on to the next slide. So what are the key ingredients of any sort of MapReduce asynchronous processing system? We want to be able to submit a job graph with the relevant input parameters, the file name, the word stems, etc. Maybe even the chunk factor. Then we need to have a set of processors that execute each job step. The step 1, the partitioning, then the counting, and then the consolidation. We need to execute with as much parallelism as possible, as much data locality as possible. Now let me briefly describe data locality. You want to move your job processing to your data rather than your data to your job processing. If you move your job processing to your data, then you omit network I/O. Your throughput is so much better. That's the way to do batch processing and high throughput applications. Fortunately, that's one of the key components of the FatDB platform, is the fact that you can blend data and processing on the same set of nodes, very unlike a lot of PaaS models, and that is a huge advantage as far as speed and throughput. So, and the last 2 things is just sort of housekeeping. You got to ensure that the job completes. You need redundancy for that. If you lose a node, you have to have some other node pick it up. And you have to ensure job synchronization. You don't want to execute the final step before the preceding steps are complete. So what I just described is built into the work queue engine and is provided for you as the developer to take advantage of. Now, the demo that I'm going to show you is basically a very simple demo. It has a web front end, and it has a few processors, and it basically is we'll show you how easy it is to do this. We have a web server with a web page that you can upload a file. You can specify your search word stems, and in the background on submit, it constructs a job graph and submits to FatWQ. The other thing is that we have built an assembly that encapsulates 3 processors, a simple data partitioner, a word counter, and a results consolidator. Now, we're running this demo on a 6 FatDB server cluster. It's sharded 3 ways with redundancy too. And we're using the previous alpha version that's not released of the FatDB Management Studio application to actually upload the processor assembly and view the queues. The FatDB Management Studio is new right now, so I suggest when you test this out for yourself, you can deploy the processor assembly manually. It's very easy to do. You just drop a file into the appropriate directory, restart it, and you're good to go. Now, one of the things that I won't cover is the actual source code itself. It's available to you. Will be posted on the website very shortly after this webinar is done. It's a full soup to nuts with unit tests solution that you can open up in Visual Studio 2010 and see exactly what the code is required to accomplish this. It's very simple, very easy, and we'll show you how easy it is to actually create these job processors and you know, get some significant work done. All right, so let's discuss a little bit about the steps in more detail. So the first phase is storing the text file into the FAT file management system. Because basically what we want to do is take the text file, upload it into the FAT FMS so it's available to all the other machines in the cluster. So you see here from the IIS web, we will push the text file into FAT FMS. And that is going to be done by the ASP.NET web page that we have crafted. And as I said before, you can see all this code in the download. The next thing to do is to submit the word count job to FatWQ. The box here is a little bit mislabeled. The FatFMS box should say IIS Web. But basically what we're doing is that job that I just showed you before, what we're doing is we're creating it into a FatWQ job, and it is a job graph. It does look like this. And we submit it into the FatWQ, and it gets queued up for execution. And as we're traversing the graph, the subnodes also get submitted in a distributed fashion so that the subnodes will execute on different nodes. And that's how we achieve high degrees of parallelism, is by using these job graphs, and at every stage the steps in the job graph get submitted to the appropriate physical machines. Now, the next step is actually the partitioning. This is where we start the heavy lifting for doing this process. So we take the input file, we chunk it up into bits and pieces, and then we store those bits and pieces into FatDB. And the actual processor that's going to be doing this chunking is a simple partitioner, and you can see that the blue node on the head of the job graph, that's the first step that we take. And once that's done, we submit the child steps to basically take each chunk and count the words that we specify. Right now, the example slide that you're seeing specifies Nantucket and thumb, and on one of the machines, it encountered one occurrence of Nantucket and one occurrence of thumb, and we're going to store those, all 12 result sets back into FatDB. The count words processor is going to be responsible for doing this counting. Now, finally, the tail end of the job graph is the consolidate phase, where we take each aggregate result set and effectively reduce it by adding them all up into a consolidated dictionary and storing that result back into FatDB. So we also need to retrieve and display the results, and that is, we take the consolidation results. We're pulling for the job completion. As soon as that job is complete, we grab those results and we display them in the web page. So before we discuss actually working with the word count sample, let me hop on over to the FatDB.net page that I was discussing. This is running on a remote cluster, and the file that we're going to be reducing now is called Sherlock.txt. I have this asset locally. This is the Adventures of Sherlock Holmes downloaded from Project Gutenberg. And I wanted to see Holmes, Watson, adventure, the stem simple, deduct, solve, etc., right? And let's submit this job and see the word count. So you can see that, boom, it was that quick. Here are the results of doing that distributed word count. All the occurrences of all the stems that we specified. Now, I've also done the same with, I pre-populated this word stem list here, and let's do Alice in Wonderland. So open that up, and let me also add a stem here, caterpillar, fire it off, and see what happens. So I didn't clear out the last results, so but here we go. It just came back. Here are all the stems that we were looking for. That caterpillar that I just added happens to occur 28 times in Alice in Wonderland. So that's what it looks like. And the full source code for this sample can be found in this download that's going to appear shortly after the demo. Give us a few minutes, and we'll we'll stick it up there for you guys. So, how do you actually work with the word count sample? You're going to download it from the website, and you're going to install a single instance of the FatDB platform to try it out. And right now, the references in the word count sample are based on the 64-bit install that will fall into the program files path. Basically, you'll have to either edit it manually or edit it, re-add those references. You can find everything that you need in the SDK folder of your, FatCloud install folder. But it's relatively easy to do it both ways. Either edit it by hand or edit it, by re-adding those references. Use your deployment web server built into Visual Studio for testing is fine. Now to deploy, once you've built the word count processor's DLL assembly, which contains the, the 3 processors that I mentioned, what you want to do is pull down the server, drop that assembly into the FatCloud add-ins FatWQ processors folder, bring up your server again, wait a minute or 3 for the server to transition into a ready state, and you should be good to go. If you're fortunate enough to get the FatAdmin working on your machine in IIS, you will be able to see the processor in FatAdmin, but with the FatMan, you can also see that there. So the current install that's on the website contains the FatAdmin portal. That's been outmoded right now by the FatDB Management Studio. So yeah, the situation is going to change a bit next week when the new install zip package is up, and you'll have the FatDB Management Studio Alpha, which will still allow you to see it. But even if you don't see, visualize these processors in the administration portal or the FatDB Management Studio, this sample will still work. And the unit test provided in the solution is really kind of the way that you want to be able to do development for making your own processors. The idea is that you make sure that the processor itself is completely robust, throws no exceptions, and is good to go before you actually deploy it. And you could very easily, do that with a test harness locally, and that should be all you need. So I hope that this brief presentation has given you guys some interest in checking out our code samples in more detail. Like I said, the assets will be available to you, and I am now ready to take any questions from folks. So let's see here. Questions.
Hey, Justin.
Yeah.
One question that came in was around common use cases for leveraging the asynchronous job processing engine. If you want to just speak to that.
Sure. It's basically, in any enterprise application, you have two forms of traffic. You have synchronous and asynchronous. Synchronous traffic is appropriate when you need a result now and you don't want to wait, and is typically driven by a consumer of your application, say a mobile phone or a web consumer, coming into your site, and they want information immediately. They're not interested in sitting around and waiting. So to handle synchronous traffic, we provide fat apps. To handle asynchronous traffic, we provide fat processors. Now, both of these are very similar in the fact that you build that using the Fat Cloud SDK. In the case of apps, they are standard WCF services with inheriting for some base classes. That'll take care of your synchronous traffic. But to do asynchronous work, you would make these fat processors to handle asynchronous work. Now, to answer the question, what is appropriate for asynchronous work? Picture the scenario where, say, you have stock data that comes in, and when what you need to do is, based on the last price, you want to value somebody's portfolio. You're not, when a web user comes in, he's not going to want to wait around while you value his portfolio, then give him the results. He would rather get cached, the latest pre-computed results synchronously. But you still have to value those portfolios, and you want to do that asynchronously. You want to basically, for all your users, stack up their portfolios to be valued, and do that periodically. That is one example of doing asynchronous work. Another example of doing asynchronous work is transcoding media files. Let's say that you have a bunch of master media files, say MP3s, and you want to downsample them and change the formats so that they're more friendly for mobile users. This is a real scenario that we use the work queue for in the Move Music application, which is a major wireless carrier provided this music service to essentially what is now today 1.1 million subscribers. But we had to do a lot of transcoding on the media files to make them applicable to cell phone bitrate and stuff like that. So basically, the idea is that you upload a bunch of master media files, you create jobs for them, and each job will transcode the master media file to another format. Another example of this, of what you might do asynchronously, is say rendering frames in an animation. You could take each frame out and separate those into separate tasks, and have a distributed rendering farm that will render each frame and then merge each frame into a clip or a segment, right? Another application could be fraud analysis. Let's say that you have a bunch of credit card transactions that are occurring, and you have to basically go through and match each transaction to potential fraud criteria. So, the fraud detection unit could be a processor, and every transaction could be a job that is input into the work queue and and potentially flagged for fraud. The uses of this are fairly endless. Anything that you can code up in C# and expose as an assembly can be turned into a processor. The question you have to answer as a developer and an architect is, in my enterprise application, which traffic's going to be synchronous, which traffic must be asynchronous? And once you've figured out which of your, which parts of your business logic has to be asynchronous, you can easily, if you can divide it up into chunks, you can certainly conquer that with the work queue. Next question.
Okay, I don't
so
have
Jeremy,
any on the line here, but there is a button for everybody, all attendees, and it's kind of a raise your hand button. If you click that, we can unmute you and you can talk directly into Justin if you'd like, or you can type your question into the question box. Maybe we'll give them a minute there. Okay, we've got one coming in here. Justin, how is this different from Azure?
Okay, that's a good question. There's really apples and oranges. There are some really fundamental differences in our architecture versus a PaaS like Azure or EC2. Typical PaaS that you're going to find commercially contain a lot of services like data storage, even some fundamental message queuing, and ability to host your own code, et cetera, et cetera. The fundamental architectural difference between us and any other PaaS is that if you look at any other commercial PaaS, they're very, very partitioned service-oriented architectures. Now, if I was a commercial PaaS provider, I really would have no choice but to have very distinct services. I'd have a data services layer. I'd have a service bus. I'd have some sort of queuing functionality. I'd have some sort of file store. But the key thing here to remember is that these are distinct services. So what happens when you have an enterprise application that has to read from a data store, that has to write into a service bus, that has to go to a file management system, and you have business logic that has to consume all this? You are incurring network I/O and latency every time that you access one of these services. A key differentiator, one of the many key differentiators of our architecture versus something like an Azure, is that we merge processing and data. And from an enterprise application standpoint, for anything that requires throughput, that's really the only way to maintain good throughput. Because one thing that we've heard over and over from Azure consumers is that, yeah, Azure's great, but it doesn't perform. Or I can't store as much data as I want in it. So the fundamental difference is the fact that we are completely integrated with your code. We are not distinct. We do not have the limitation of having distinct services. You can blend the two. Now, that's one of the reasons why we're different from Azure. The other reason why we're different from Azure is that they don't have a work queue. They don't have something that can easily perform job graph type functionality and route the processing to your data. you could probably cobble together something. I mean, it's fairly easy to come up with the basics, but you couldn't come up with something that is performant and scalable. It's just not going to work.
Another question came in about samples being available in terms of the downloads off the site. Are these, I guess, the samples you've presented today, as well as other samples available when they download the software?
Yes. Let me explain to you guys what's going on right now. Right now, we're in a very exciting time. We are going to TechEd next week, and we've been nominated for Best of Show in the database category, and we're also rolling out our new management studio, the FatDB Management Studio, which is really cool. It's really exciting. It's in alpha stage right now, but we're scrambling to get everything ready for next week, basically. So even our website is in a bit of flux. So what we are going to be doing today and in the next couple days is updating the website, posting the latest quick start guides and samples, pushing up the new installer, et cetera, et cetera. So right now, none of this stuff is up on the website. What we'll do is we'll put the word count sample up there. It's going to be enough for you to download the sample, check it out, see what all code that there is, of which honestly it's very little code to do what I just showed you guys, and you'll be able to do the the basic sort of sniff test on what we're doing. Next week, I encourage everybody that's listening to revisit our website, which will have a new look and feel, download the latest zip package, and everything that you're looking for will be in that zip package, all the quick start guides. And this work queue sample is a quick start guide. So you should be able to play around with it. And yeah, definitely check back in the next next week and in the next few days. Lots of really cool stuff is going on right now. Really excited to deploy the new versions and to make a strong showing at TechEd. And if you guys have any questions in the meantime, please reach out. Our goal is to make you successful in using our products. So we're there for you. We want to ensure that you get the best experience possible. But bear with us while we're kind of under construction, because we're scrambling to get everything done.
Okay, I don't see any other questions coming in, Justin. So I think at this point we'll go ahead and wrap up today's webinar. If there were any other questions that we couldn't answer, you couldn't unmute, etc., feel free to shoot us an email at info@fatcloud.com. You can also call us directly. There's a phone number provided on our website. We really appreciate everybody attending today. And Justin, thanks for the great presentation. So with that, have a tremendous day, and we will look forward to the next webinar.
Cool. Thanks, guys. Appreciate your time.